This is Trip Zero here, and as I promised, I was going to do a bedside review on power management while in the backcountry backpacking. And what I have here is just a simple little case I got on Amazon for electronics, and inside I have my power management solution. So the problem I'm trying to solve is I'm back in the backcountry and I have several devices that require power. How do I keep those from running out of power too much? And the primary device that's not here is that would be here is a phone, which I'm using to record. So just imagine there's a phone there, and the phone I'm using as not only to take pictures, but also as a GPS device and among other things, music, etc. while I'm in the backcountry. So other devices I have here, I have the flashlight, which I talked about in another video, and I have here a Garmin Glow something or other GPS. I can't remember the model number off the top of my head, but it does GPS satellites as well as the Russian GLONASS satellites. So it gets a really good fix, a lot better than my phone, especially my phone is going to have a hard time without connectivity getting a GPS fix. So this is great. It's Bluetooth, and it has a built-in lithium-ion battery that's rechargeable. And then we talked about this. This has the big old 18650 battery, lithium-ion. And how do I keep that charged if I anticipate it will run out? So this is my solution. So in this box, I'll break it down. I've got a Goal Zero Guide 10, and this has a USB port for charging, and it's also got a nice LED and a client port for, if I can get it to focus, man, that's terrible focus. Sorry about that. So I can charge this. So inside it's got 4 AA rechargeable batteries, and there's an adapter that it comes with that you could put AAA's in. And I think this is a superior backup battery solution. So this can charge your phone up to about 4 times if the batteries are full, which should last, at least 4 days. And then I have, this will charge the 18650 battery for the flashlight. And it also hooks up to a USB port. So I've got a cable here. I can plug one end into the device, the other end into the battery pack, and I can charge this battery from these batteries. Tested it out this morning. Worked well. Charged the 18650 battery just fine. And in here, I'll probably have an adapter to convert this micro USB into something that fits my phone. And then in here I can put in some extra AAA or AA batteries if I want. Behind here I have a cable I'll talk about later, and an LED, nice bright LED that connects to USB. You can see there. So that's pretty good. This is a good reading light, and I just plug it in, and this wire is kind of flexy, so I can arrange it how I need to. Get that back. And then of course up here I just have my USB cable. So that's pretty much it. Now what happens when this runs out? That's a problem, right? So how do I keep this full so I can keep all my other stuff recharged? Well, there's a couple solutions you could do to Well, actually, let me back up. Before I go into that, let me tell you why I think this Gold Zero Guide 10 is a superior solution of the battery pack. For example, let's compare it to, zoom over here to the computer. This Limeaid Blast battery pack that's 15,600 milliamp hours. With 4 AA batteries and 4 spare, this is about equivalent to this. So at 2,000 milliamp hours per battery times 8, that's 16,000 milliamp hours, and that's pretty close to the, the 1,500 or 15,000, sorry, right there. So that right off the bat, the power is pretty equivalent. The price on this is also pretty equivalent. You can get it around 40 bucks, while the Limeaid one is about 50. But the difference, I think, is in the options, the configurability. So, for example, I don't necessarily have to, well, first off the bat, this is power capacity per ounce. This is superior. The Limeaid Blast is about 1,218 milliamp hours per ounce, 1,200 milliamp hours per ounce. This, with all 8 batteries, is 1,600 milliamp hours. So off the bat, you're getting 400 more milliamp hours per ounce just by going with this. But I have options. I don't necessarily need, if I'm not going on a very long hike, the 4 extra batteries. I can limit it in half. I could cut the batteries in half and just use 4. In that case, I still, with only 4 batteries, I still have a superior power capacity per ounce. With just 4 batteries, I'm at 1,333 milliamp hours per ounce. And I can cut it down even more. I can cut the weight down even more if I want to. Instead of having, the 4 AA batteries, I could bring in this adapter, put in some AAA batteries, and all of a sudden, I went from 10 ounces down to 4.2. I cut it in half. So I have lots of different options to save weight, which in ultralight backpacking, you want to save weight as much as possible. And for me, I want options. So what happens if this runs out? Am I out of luck? No. Because what I have here, go grab it, move it forward, is a pot. And that's not just any old pot. Got a nice cup here, nice big pot. But what is this? This is a wire coming out. Why is there a wire coming out of a pot? That's because this is a power pot. On the bottom here, covered in fire goo, is a thermal electric generator. Fire heats up the bottom. You put cold water in the top. This is primarily boiling water. And the difference in temperature, the delta, creates an electrical charge, which comes out through this wire. And I hook it up with the cable here, plugs in here, and it comes out as a nice USB port. So it converts the energy from boiling water into about 5 volts that I can plug USB devices like my Gold Zero, and I can just charge while I'm boiling water while I'm cooking. So I've taken this out once overnight, and it worked really well. I just charged this. I didn't even bring extra batteries because I didn't need to. It was only overnight. And I kept a charge of my phone the whole time. I even charged my GPS device from it. So it worked really well. Now, on a longer hike, maybe 5 days or more, maybe this won't be enough. Maybe you're not cooking long enough to really charge this thing. It does output 1 full amp at most, and you can accrue, you know, it will go down as the delta decreases as well. So if when you're boiling water, when you first start it and you have cold water, the energy output will be higher because the delta is higher. But if it's the water heats up, then the delta slowly gets down. So if you're like melting snow in it, you're going to get a good charge out of it. But if you're just boiling water for a long time, it'll probably take a lot longer to charge things. So what if that's not enough? There is another solution, and Goal Zero also makes several different types of portable solar panels. This one's a 7-watt solar panel you can strap onto your pack. Instapark also has one that's 10 watts, and I think it's a 3-panel thing you can strap onto your pack. These are pretty pricey, 79 bucks. I think the Instapark one's a little cheaper, $40 or $50. In fact, it might recommend it down there. No. But they're pretty pricey, and I haven't tested it out. I want to, you know, strap one on my pack and try to charge these things as I'm hiking rather than as I'm cooking. What I think I'm going to do is I think I'm going to make one. Grab a 10-watt solar panel and get a the right kind of power supply, convert it to 5 watts or 5 volts, and strap it on my pack and see how it works. Because I think I can build one cheaper than these, a little bit cheaper and potentially better. We'll see. So that's another solution that I'm going to explore later on, but for now, this is how I plan on managing power. Battery pack, and then keeping it charged with the power pot. I think that's it. If you have any questions, I guess post on the YouTubes, and I might see it. But that is my bedside review, power management in the backwoods. Cheers. Trip Zero out.